virtual programs given the status of our world and the world of education. This series is sponsored by Lake Champlain Sea Grant, UVM Extension, and SUNY Plattsburgh's education program known as Watershed Alliance. Lake Champlain Sea Grant develops and shares science-based knowledge to benefit the environment and economies of the Lake Champlain Basin. Watershed Alliance aims to reach K-12 students and their teachers throughout the basin. Our goal is to increase awareness and knowledge of watershed issues in youth throughout Vermont and New York. The Zoom a Scientist series, like I said, was created not too long ago in response to the need for more virtual programs. All of our webinars are going to be uploaded to our YouTube channel shortly after the presentation. That way you can view and share these presentations with other folks or revisit presentations that you might have missed. And without further ado, Ashley's going to introduce today's speaker.
Great, thanks, Nate. So today we have a special guest with us. We have Cody Warner from DeepTrekker, and actually I'll tell you a little story as we get started here. So I work in the Rubenstein Ecosystem Sciences Laboratory here at the University of Vermont for Lake Champlain Sea Grant with Nate, and I'm the Watershed and Lake Education Coordinator. So we do a lot of work in the education and outreach realm, sharing the research that's happening here at UVM and in the basin. And one of the pieces we like to do is our demonstrations to kind of share what's happening. And so our research vessel captain at the time had seen a DeepTrekker model at a boat show and came home basically and told us, oh, you have to get this piece of equipment. This is really cool. He said DeepTrekker was doing really cutting edge work. And so at the lab, we did a little research and we were pretty impressed with kind of the maneuverability and the lightweight technology that DeepTrekker was coming up with in the world of remotely operated vehicles. So naturally, to kick off this session, I was like, oh, Cody, do you want to come talk a little bit about DeepTrekker and kind of the work that you are all doing? So Cody's here with us. Cody is the sales manager for DeepTrekker, and he's going to talk all about kind of the work that they're doing in this realm. Cody's been with DeepTrekker for about 6 years and actually started with the company very early on, was one of the first kind of 12 employees. And he actually grew up in the hometown of DeepTrekker too, in Ayr, Ontario, Canada, which is in the Great Lakes. So very familiar with some of the freshwater challenges that we're facing here in the Lake Champlain Basin. So I will turn it over to you, Cody. And basically we're going to kick things off with getting a little bit of information on how DeepTrekker came to be, and then a little bit more about how the various ROVs they have are used. So thanks so much for being with us.
Thanks for having me, Ashley. I just want to make sure I get my technical parts right here. Can you hear me okay?
Yeah, I can see your screen. I can hear you. Everything is all good.
Perfect. Well, thanks everyone for coming out and listening to me talk about DeepTrekker. I think it's a great opportunity to see how we're using our robotics, but then also hear a little bit about from you guys about how you could potentially use it in your research. In terms of DeepTrekker as a whole, what is it that we do? We make submersible robotics. So whether it's crawling robots or swimming robots, we make things with cameras and tools on them that you can move around with a joystick and a controller. I'm going to get into, what is it that we make and then how are they being used. But first, I kind of want to tell you the story of where it is that we started. So right now we have 70 employees. We've got 2 offices, one in Chile and then one here in Canada. We have over 20 engineers at this point now. We've shipped robots into 100+ countries. So, very much a success story from a business standpoint. But where we started actually was 10 years ago. It was 3 friends on a boat in Lake Huron, and they dropped a flashlight overboard the boat, and they thought, oh, I can make a robot to go get that. So they started doing a little bit of searching online, and they found that ROVs or any sort of vehicle that went underwater were really big, complicated, expensive pieces of equipment. So what they wanted to do was set out to make something that was just simpler, easier to use, more affordable, and portable, not needing a crane or extra equipment to get in the water, just be able to throw it in the water. So they came up with a really rudimentary design, and they put up this website, so a really rough looking website to start. And based off of a patented pitch system with the ROV. So you can see in the screen here, it's a little different in shape than the picture you saw last. That was actually to hide the patent pending at that point so that people wouldn't steal it. But this was the first website, and a Norwegian fish farm supplier found them on Google, and that was the first order that we got, was a 10-unit order for fish farms in Norway to do inspections of their nets. That paid for the parts to get started, and then the first 300 orders from there were mostly from Chile, Japan, and Norway, and a few in Canada. And that was all done out of the basement of one of the engineers' houses. So they were building in the morning, and then they were calling customers and drumming up new business in the afternoon, and engineering and fixing things as they went. And so that was the first 300 units. That was when that paid for enough to get our first really small factory in our small town here in Ayr. The small factory at that point was housing only 4 people in sales and marketing. I was the lone sales guy at that point then, and the 3 engineers, and then approximately 6 to 10 technicians in that time. And then at that point, we started seeing more markets, more opportunities, more applications. There was, it started out as kind of here's a toy to go look at things, look for flashlights, but we've evolved a lot as a company. We've really grown up because we've just been open and listening to all the different possible applications that you can use these robots for. And by listening to, hey, you know what, I want to go look at an intake gate at a dam, or I want to go pick up a piece of evidence that was thrown into the water, or I want to go look at the bottom of a boat. Just by listening to customers with those questions, we've kind of discovered, okay, there's a lot of other different ways that we can use these things. So what is it that these things are? What am I talking about here is the ROV first. You see on the left, that was our first product, was the DTG ROV. This one here is a camera, and then you've got 2 thrusters on the side, and then you can actually rotate the body to be able to move it around in the 3-dimensional space. It's got the camera on board that can rotate as well, so I can get a good look at everything as I'm swimming around. But the neat thing about it is that you can put a bunch of different attachments on it. So I can put things like a grabber claw if I wanted to do a species sampling, or if I want to pick up coral, or pretty much anything I want to grab onto. There's sediment sampler attachments, there's water samplers, there's water quality sensors. So if I want to do a map showing dissolved oxygen as I move around a lake, I want to see, is there changes at different depths at different locations, I can do that with this tool as well. And then you'll see on the right, we've got our Revolution ROV. So this is the bigger brother. This is the more powerful, deeper depth rated one. The smaller one, the DTG, is about the size of a basketball, and then the Revolution is about 3 times that size. The Revolution really meant for more offshore applications. So if I was, say, inspecting the offshore wind farm, or if I was doing research in the ocean, seafloor research, maybe I'm doing surrogate research on mines or something along those lines, the Revolution's a great option for that. Other tools that we make now, so we started with the swimming vehicles, but we discovered that customers were trying to shove these ROVs into pipes to do pipe inspections. But we knew that we could make a tool that was maybe a little better suited for that. And we took a look at the crawler market in the world. Like, how are people doing pipe inspections now? How are people inspecting sewers? How are they inspecting stormwater pipes? Well, they were using large, complicated equipment that's mounted in trucks, and it's very expensive. So we realized, we could apply a lot of the same principles and a lot of the same design principles to a crawler, a wheeled vehicle to be able to drive down the pipe. So that's where these 2 vehicles were born. The one on the left, the DT340, is meant for larger diameter pipes, and then the DT320 is meant for smaller diameter pipes. But they're based on the same concept. I've got a camera out front of it, and I'm able to move it around to be able to get a look through the whole pipe. And then I've got my body and batteries on the back, and my motors to drive this camera around. And the fact that we have batteries on board is really one of the most unique features, is that has never been done on crawlers before. Typically, they're running with a big generator in a truck. So again, really keeping things easy and simple. And then we started seeing some other applications that were being, that the ROVs were being used for that maybe they weren't the best tool for. On the left, you see the DT640 magnetic crawler. What that is those wheels are actually have magnets inside of them. So that crawler will attach to a wall, and then it'll be, as long as it's steel, of course, and then it'll be able to drive along that surface. So what's great about that is if, say, I'm doing like a hull inspection, I want to put my vehicle with the camera on board to be able to go and scan the hull without having to worry about current. I'm attached to the surface that I'm inspecting, so I don't have to worry about trying to fight current in really high energy environments. Then you've got on the right, it's actually the same vehicle, same chassis, three-wheeled vehicle, but it's now just been purpose-built to be a tank vacuum. So this vehicle here goes into the bottom of a water storage tank, and then you're attaching a hose. You can see in the front of the right there, where the hose attaches in, the hose attaches to a pump outside of the tank, and then you're able to drive this around and clean the bottom of the tank. Typically, water storage tanks, to be cleaned, what they have to do is they have to drain them, which takes 2 or 3 or 4 days to drain it. You then put your city at risk because you don't have a backup water supply. A lot of the time it's used as a fire suppression tool. Then you're putting your city at risk by draining it. The other option is to put a diver in to take the vacuum down, and it's just not a safe activity. So being able to send a robot in is a lot safer and a lot more cost effective to be able to do that type of job. And then lastly, we have our drop camera. So the DT pod is actually being used it's for a variety of applications, typically as an underwater surveillance tool on fish farms or at a port, but we've been starting to see it used as a field science tool. So one example is Memorial University on the east coast of Canada. They're using this to monitor certain sites. So they're just placing it down, and they're monitoring for species behavior. They're doing some population counting, and they're just leaving it there for 15 minutes, and then they pull it back up, and then they move to a new location and monitor again. It's just a quick and easy way to get eyes underwater. So those are the different tools that we have, but really the main goal of all of our tools is this, based off that original concept that was come up with on the boat in Lake Huron. It's, we want to make things that are really, really easy for virtually any operator to be able to pick up and drive right out of the box. We don't want people to have to, have months and months and years of training to be able to perform these crucial inspections and tasks. The second kind of goes in line with an easy to use robot is, make it portable, make it really, really simple to get in the water. People aren't going to want to pull out a crane, especially I think for research purposes. You're in really remote areas. You want to be able to switch locations and be able to monitor species from a variety of locations. You don't want to have a bunch of equipment. So, a great example is there's been some research done in the Arctic. It's not easy to get equipment up there. So forget about moving around once you're up there. Just shipping equipment up there, you want to be able to have everything be able to get on a small air freighter and be able to get places. We even have for our DTG3, it's a single case that you can use as a check bag on an airplane. So really, really easy to get around. We wanted to make them durable though. We didn't want to go, you're wanting to make things easier. You want to make things portable. The last one there's affordable, but we didn't want them breaking all the time. You wanted to have something that a customer had a lot of trust in. So we did set out to design each and every piece and part that went into it, especially made for DeepTrekker, so that it would be built to last. And then if anything did go wrong, we could make changes that would improve on it over time. Those first robots we shipped, a lot of them broke, but then what happened was we learned from that. And now our robots 10 years later are just, I want to use the word bulletproof. They're amazing on the types of harsh environments that they go into and that they withstand is really incredible. So I think that that's one of the most important points of these 4 points is that we want to make systems that really are going to last for people, especially if you're applying for grants, you have limited budget, you don't want to have to worry about paying for repairs or replacements all the time. I'll switch now just to talking about some of the applications. I'm going to talk really generally about how the different industries are using our ROVs, and then I'll kind of leave it to you guys in the Q&A if you've got specific, applications or ideas, and or if you're wondering what it is, then just throw it out as a question. Happy to answer it. This first here is a picture from a power plant. So it's actually a hydro plant where they were putting the ROV down, and they were looking at dam intake structure. So they wanted to see, what's the condition of the gate. Are the bolts corroded? Is there a blockage in it? Just general getting eyes on the target. But in general, utilities are using these, so whether it's a city or a power company, they're using them to inspect submerged structures. That could be anything from a water storage tank. For example, a coal power plant has a cooling tower tank. You've also got a lot of intake structures in virtually every type of power except for solar. So you want to be able to monitor these as the water's coming through, it's battering these structures. You want to make sure that okay, when do we need to repair it? Can we put off maintenance activities for 5 to 10 years? Because that would save us a lot of money and then allow us to prioritize repairs in other areas of our structures. Here's a picture here from a fish farm. So fish farming is a big part of our business, aquaculture. ROVs are a great tool because it's a camera, it's swimming around. You're able to swim around the net and look for holes. These cages are where fish are being farmed. Typically, we're working on salmon farms as our most common species that ROVs are implemented on. But instead of sending a diver down, or instead of ignoring your nets, you're able to now get regular eyes on them and find out when there's a hole before it's too late, before you have an escape. An escape is bad for a variety of reasons. One, your entire business is underwater. You don't want to lose all of the product that you're growing, but also if there's any concerns over the environmental well-being when there's an escape that happens, you got to make sure that you're protecting the environment around the fish. So that's the key for ROVs, but you can also put tools on them. So whether it's net patch tools or what we call mort diggers, so being able to push any morts into the vacuum systems that are sometimes on these farms. There's a variety of ways that you can use ROVs at a fish farm. Here's a picture here from some lake research that's being done here in our area. A great tool, one, to get eyes again in different areas underwater for ocean research or for lake research, but also you can use it for tools, and I'll go into the tools in a second. But if you're ever trying to monitor and get an idea of whether it's species or whether you want to take samples, ROV is a great tool for your program. We also then have a lot of defense applications for our ROVs. We see navies around the world using ROVs. There's kind of three main applications. One is first response. So if you are responding to an emergency, or if you're responding for purposes like evidence recovery for say a case. Also, we see it used for inspections of hulls of vessels for maintenance purposes. You want to make sure that your ship hull is in good shape, that it's clean, that it's not corroding. But you also want to look for security purposes as well. You want to make sure that everything it checks out for that hull. And then lastly, also investigating sea floors, making sure that everything is safe there as well. And then another industry is this here's a picture from a west coast of the US shipyard doing a hull inspection on a barge. So really any seagoing vessel should have regular inspections done. And it's very costly to pull ships out of the water. So it's called dry docking, when you place a boat into a little lift, and then it'll lift that vessel out of the water and you can go and look underneath it. Well, just that process for a cargo ship, that process will cost millions of dollars to do, and it takes a lot of time. So the alternative is to look at it while it's in the water. And there's two ways to do that. One is to use an ROV, or you use a diver. And using a diver, it's going to cost more, but it's also very dangerous. So ROVs are just a great tool to be able to get a good understanding of what's going on in the bottom of your boat. And then here's a shot here of our pipe crawler about to go into a sewer. So yeah, the ways to evaluate sewers, one, you can wait for problems to arise. So we could have issues where your pipes are leaking and they're broken, and you wait until that happens, and then you dig up the pipe and you fix it on the spot. But there's now a lot of ways to do what's called trenchless repairs. You can actually fix these pipes while they're in place. But the best way to figure out an issue before it reaches a point where you need to dig it out is to inspect. So you want to get eyes in that pipe and be able to understand what the problem is. What kinds of tools do we need to use for the repair? So that's where our robots come in, is that, you know, a great way to evaluate the condition of a pipe. And then I've got a couple pictures here, the last couple slides here, just showing different ways in research in particular that the ROVs are being used. This right here was by a researcher in New Brunswick area. So his name was Sean Robinson. So what he uses his ROV for is to actually do benthic surveys around fish farm sites to determine what's the environmental impact of what of the fish farm being there. So this is a multi-sampler device that he built himself and then attached it to our grabber. What it does is it takes 5 different samples, so it's both water and sediment that he's taking in each of these samples to be a kind of a representative sample of an area that he's testing. And what he determined from his research actually was that the fish farms in that area in particular were improving the environment. So they were actually creating more biodiversity and improving the health of that area, which is great. But I think that the key is that he was able to use this tool, which is a much lower cost way than sending divers in to take these samples regularly or to use other sampling devices that are out there. And then we also have, this is one of my favorite pictures from DeepTrekker. This is so it was Plymouth University that it was funding the study. It was British Antarctic Survey was the group that went down. And so what they were doing was they were using the DTG ROV to do surveys of sea ice thickness. So they were actually going through, they would drill a 14-inch hole in the ice, dive the robot down, and they got specially made little wheels on the top there. So then they could drive along the bottom of the sea ice, and then anytime the ROV would kind of dip up, they would know that there was a break or a weak point in the ice that they could then evaluate, okay, how much ice is left here, and they could get a closer look that way. They also use it to do surveys of the environment as a whole. So yeah, in terms of applications, you can imagine, you know, I can get a look at different things, but I can also use this now as a tool to carry different payloads. So I can use it to carry a little grabber claw to be able to retrieve objects, to take samples, to put different sensors that you want to measure on as well. We've got a dissolved oxygen sensor. We've got a multi-parameter sonde, so a little wand that you can put different sensors and tools into, and then it mounts on the bottom or the top of the ROV, and then you're driving along, and now I'm able to evaluate the condition of the water at different locations. I can understand, okay, this is what changes at certain depths. And that's the big advantage of using a moving vehicle instead of just a static sampler that you're dropping in the water, especially if you're going into areas where it's difficult to access by boat or by just walking in. So that's just a snapshot at DeepTrekker as a company, but definitely happy to answer any questions that you might have, any comments, and go from there.
Great, thanks, Cody. That was a neat little insight into what's happening at DeepTrekker and kind of I guess I wasn't aware when we purchased ours, the various customers that you have in such a diverse set of demographics in terms of what the equipment is being used for. One thing I want to ask while folks are getting ready to get their questions in. So if you have a question for Cody, please pop it into the Q&A box, and we will moderate that. I did want to ask you, Cody, my first question is, so one thing I'm super curious about, and I know this has come up with our team here at the University of Vermont, is looking at what is the impact of having an ROV in an area versus a diver in terms of sound and just kind of that aquatic presence. And I'm curious if you have any kind of stories from the field in terms of folks that you've worked with that have used these vehicles for research and what their kind of findings have been so far.
Yeah, I'll say that we've we have not measured the acoustic signature compared to a diver, so we don't have specific data. But that being said, just from a more anecdotal standpoint, we definitely have seen that the ROV interacts well with fish. They tend to just swim toward the ROV. They're curious. They look at it. They're not really afraid of it. And the shape and design of it, it really doesn't have an impact on the species as a whole. So we found that researchers that are using it rather than putting a diver they're not impacting the environment as much. They're not having as much of an impact on the behavior of the species that are there. And the sheer size as well. I mean, especially if you're doing any research near the sea floor, you're not going to be stirring up the environment nearly as much as you would as a diver.
Yeah, it'll be really interesting to see in the next 5 years as this technology kind of kicks off what research is done actually to evaluate that and to see what may be kind of new territory with these remotely operated vehicles.
Yeah, for sure.
I have a question for you, Cody, and it's fairly specific. So if you don't have an answer for it, that's fine. Or if you need to protect some IP, that's also fine.
Give me a shot here.
Yeah. So I don't know if you've seen the film Chasing Coral, but they had a really tough time with leaving long-term video and photography components in the water to monitor coral reefs. And I'm wondering if you've had any requests or if your company is thinking at all about what sort of like more long-term robotic audio, video, or maybe not audio, but video and photography capturing that could be done.
So you mean kind of like a permanently placed camera that's monitoring over time?
Right. Yeah. Maybe, something that's in there for a couple weeks, a couple of months, something in that range.
Yeah. So the drop camera, the DT pod, that thrusterless vehicle, that one is already installed permanently in locations. So we've seen success from that standpoint, just holding up over time in saltwater or freshwater. In terms of monitoring and typically it's been in ports or fish farms where it's permanently mounted. In terms of monitoring kind of open ocean environments, we're definitely looking into that. And we've got a project right now that we're working on with an offshore fish farm where they're able to sit in an office back in 50 kilometers away, and they're able to monitor the nets from there. So that we're definitely already kind of in that phase, but we haven't seen it requested for research purposes at this point.
Great, thank you.
Does that answer the question?
Yeah, that's perfect. Thank you.
What other questions we have here?
Let's see. I'm not seeing any questions come in from the audience yet. Certainly, if you do have a question, type it into the Q&A box. I actually have another question while I have you. So you talked a little bit about like working back and forth to develop new pieces of robotics. I'm wondering if you have any stories that stand out to you of like someone using one of your pieces of equipment just totally not as it was intended, that like led to a new development in the company, or like a big problem that someone ran into in the field that made you kind of like, I don't know, smack your forehead as a team and go, of course we should have done this thing.
Yeah, there's tons of those. I mean, the most common one is the GoPro on a stick. That's probably the most common from a standpoint of, it comes up and it's like, okay, yeah, that technically works, but really, like, think about how your time's being spent. I think my favorite one, I already kind of talked about the pipe one. That's one of my favorites, but to expand on that a little more, that one gentleman in particular in Florida, he would not only try to use his ROV to do inspections, but he was also putting himself in as a diver into a pipe. So I'm a little claustrophobic. I don't know, I wouldn't do well in that environment, but he was going into as small as a 24-inch diameter pipe and putting himself, imagine dive suit, dive gear and all, and he's going 500 feet into one of those pipes. So that was a head, yeah. But yeah, other ones, I mean, there was more of a cool one in Zimbabwe. they were trying to do well, they were filming hippos and monitoring for both research purposes, but it was also a documentary where they put on a big cinema camera. Like, our cameras are good, but they wanted to make like a video for National Geographic. So they had this big camera that they put on it, and it was on a crawling vehicle, and they were using it so that they could keep a distance away from the hippos. One, because a hippo would kill them if they were in there, but then also it was so that it would not disturb their environment. So we actually have a crawler in Zimbabwe right now that's following hippos around. But my favorite part of that was we got a service call because a hippo had stomped on the camera and had broke the cable off. So we it survived the stomp, but it was just a hilarious call to get. It's not your typical one.
Very cool. Thank you.
That's great. We have a question coming in from Ellen Marsden, who's a faculty member here at the University of Vermont, and she's asking, as a scientist, equipment that is easy to modify or can accommodate add-ons is great. Also, manufacturers who are receptive to new ideas and can collaborate with scientists directly are great. What do you prefer, adaptable gear or collaboration or both? So I think she's asking, like, should she be making her own adaptable equipment, or do you want to hear from her and do you want to know what adaptation she's making, because it might fuel future kind of ideas?
Yeah, I kind of heard that as and maybe I'm wrong, but Alan, I heard that as, do I have to do this, or is someone else able to help me do it? And the question for us is, we're definitely open to have any conversation about any add-on. There's some things that are better to collaborate on. A good example would be software. If you're wanting to make changes to software related things, sometimes that can be a little more difficult to do on your own. Hardware things, it's especially if we're talking about, say, a sampling tool, we're actually a pretty good company for machining things out of nowhere. So if you have a very specific design for how you want to do a sampler, we can usually at least offer some advice on how to do it. So in general, to give a short answer to that, I prefer collaboration, because we can at least point you in the right direction, even if you end up having to do it yourself.
Yeah, that's great. Thank you.
Great. There's also a question coming in from Cami, who's asking about the net patching tool. So how would the net patching tool with the ROV work for fixing the nets in the fish farms? Does the ROV find when there's a hole and signal the tool to fix it, or just just looks like looking for some clarity around like the functionality of that net patching?
All right, I'm going to quickly, rather than me talking about it, because it's a little easier to show it. So I've got a little video here, and then I'll share my screen, and then we can go from there.
Sounds great.
Bear with me.
Yeah. No problem. Always up for a good visual explanation. It's good to mix.
I've never had luck with Zoom and sharing videos, so I apologize in advance, Cami, but I hope that this will at least give you some idea of how it's done. So let me just find.
Nick, could you start a drum roll, please?
Yes, now it's getting dramatic.
Yeah, I'm expecting a really well done video here.
Yep.
Oh no.
No pressure.
All right, I've got it now, so I'll just do a share screen. Okay, so we can see this.
Looks good, yeah.
Here, there's kind of these two bars sticking out in front of the ROV, or they've got little screens, and what they're doing is they're grabbing onto the net, and then they're able to and then you're able to kind of walk that onto the where he's kind of crunching it onto the net. He's gonna push it together. And then, there we are. So the patch itself is not meant to be a permanent fix, but what's nice is you're able to wait to have to call your divers. You don't have to call emergency divers in that case. But you can see kind of how people can come up with cool tools for it.
Yeah, and so you were a little hard here at a couple points, so I just want to verify. So that patch that they were putting on was prefixed to the front of that kind of arm, and it was basically pushing that into the net, the area of the net that was breached.
Yeah, exactly.
Neat. That is super cool. We have another question coming in. Janet's asking, are each of these ROVs always attached by a cord? This is a great question. Or can they also have an option of being wireless? Do permanently installed ones need to be retrieved for charging? That's a great question.
Great question. So in terms of, for the first part, the wireless versus wired, video signals and controls can't transmit through water. Neither can GPS. So none of those signals that we're used to above water are able to work underwater. That's why the cable's there, is you need to be able to transfer your video for an ROV. There are wireless vehicles that go on pre-planned paths called AUVs, but they're used for totally different applications than an ROV. Typically, they'll actually work as complementary vehicles. So you'll go and send an AUV out, it paints a picture of what's the sea floor, and then I'll look and I'll see, okay, that target looks a little interesting and that one looks interesting. I'm gonna go look now. I wanna get a live view so then I can know exactly what I'm looking at as I'm looking at it and make adjustments to it. As well as taking samples. You would never send an AUV out to take samples, you'd send an ROV out. In terms of for charging purposes, so yes, our systems are battery powered, but most of our systems can actually be trickle charge from the surface. So it really depends, you know, is it a buoy up top or is it connected to land? Either way, if you've got some sort of power source, you can actually trickle charge batteries as you go. Yeah, so application specific, but short answer is yes, you can have it permanently powered.
That's great. And that actually, so I had a question for you, thinking about, so from my experience, at least the software that DeepTrekker is using does give you really valuable information. It is quite accurate in terms of some of the coordination points. It's also giving baseline information like the temperature of the water. It's giving you the depth of where you're oriented in the water, which I think is incredibly helpful. I'm curious, and I don't know if you can share this, but I'm curious what other pieces you might expect to see in the next 5 years from a company like DeepTrekker that is kind of on the edge of innovation in the field of ROVs.
Yeah, for sure. I think that one of the neatest things that we've already recently come out with this year was GPS logging. So when you use, because underwater GPS doesn't work, but there's alternate technology that you can use to get your position. One way is USBL. It's an acoustic device, so picture it's like the shape of a pop can, you drop it in the water, and then there's a transponder on your ROV, and those two are talking, and now I've got a position of the ROV relative to this point, and then what we've done on our software, so what your controller would be running, is we've integrated Google Maps and that USBL technology, so you can now watch your ROV's position as you're moving around underwater. But even cooler for research purposes is I can log all the data that I'm collecting all from that controller and log it into not only a video, but also into an Excel file, like a CSV. I can log it into a GPX file. So now I've got a Google Map file with points that I set. So every time I found something interesting or every time I took a sample, I can click, record that point of interest. And then from there, I've got this nice file that shows all the data that I collected, and it's all from that handheld controller. In terms of next steps, and you say the next 5 years, in robotics world, 5 years is like an eternity, so I have no idea where it'll be, but I can tell you that within hopefully the next year, some of our systems will be running autopilot. So being able to pre-plan a route and not need an AOV. You can have an ROV that would do the pattern and then go and investigate areas closer that you want. But I also picture machine vision playing a big role as well. So being able to start identifying things without human interaction, be able to pick up certain targets and say, okay, that's definitely coral, that's not, and then evaluate more from there.
Yeah, that's really cool to think about. I love the idea that in robotics that's an eternity. That makes a lot of sense. All right, well, we are, I think, going to start wrapping up. If you have any other questions, feel free to toss them in, and if they're quick, we can definitely address them. I am going to, I think, Nate, are you going to launch the feedback poll right now? And I'll go into talking about our couple little components. So you should see a poll popping up on your screen right now. Go ahead and fill it out. We are always so curious how this experience was for you all virtually here with us today. And then I'm going to share my screen and we're going to just cover a couple last minute little details here before you all go. So the first is, if you're interested in kind of learning a little bit more about this, if you thought some of the pieces that we talked about today with Cody were incredibly interesting, we really encourage you to go to this website, to go to deeptrekker.com/industries to kind of learn a little bit more about all of the different fields that these ROVs are being applied into. And then also to think creatively about how else, now that you've learned a little bit more about these ROVs, how could these be used in other sectors where they're actually not being utilized yet. And so share that with us if you find anything cool on Instagram and on Facebook. And then, as always, we want to tell you about our next upcoming webinar. So our next series is going to be Climate Change in the Champlain Basin with Kurt Stager from Paul Smith's College. And so Kurt has been involved in a variety of long-term monitoring projects in the Adirondacks and is going to kind of give us an overview of his work and his findings and kind of where things are headed here for climate change in our region. So don't miss that. That'll be Tuesday, October 13th at 3:30. And I think Nate's gonna pop the link into the chat box for everyone. So huge virtual round of applause for Cody. Thanks so much for spending your Friday afternoon with us and letting us learn a little more about DeepTrekker. I know I like to geek out on this stuff. It's really cool to me and it's amazing to think about what will be coming in the future. So thanks so much for joining us. We hope everyone has an awesome weekend. If you have any questions or you want to reach out to Cody directly, maybe about any of the products he mentioned here today, Nate has put his information in the chat box and we hope to see you again soon. So thanks so much.
Thanks for having me.
Thanks, Cody.